longer a simple, just a piece of paper, right? It's a three-dimensional paper, three-dimensional object with dimension. So from this side, the electric field lines are going in. What's the A? From the left side. What's the direction of the A vector? The A vector is this way, right? Comes out of the surface. So if the surface is a closed surface, right, the A vector on the left side comes out, and the A vector from the right side comes this way, and the A vector here goes out, the A vector from the bottom comes this way. So the A vector is always coming out of the surface of a three-dimensional surface. So from the left side, the electric field lines are going in, and the A is to the left. That means their dot product is negative, right? So then the flux from the left side is going to be negative EA. And then the flux from the right is going to be positive EA. And then this is a 0, so we have the total flux. Okay? And so the total flux is 0 in this case. Okay? Now here is what the total flux is measuring. The total flux is asking the question, if you take this closed surface, are all field lines that are coming in, are they also going out? Or do some field lines come in and they get stuck somewhere there? There's a sinkhole there. There's a sinkhole there, and they don't all come out. The water equivalent of it is to ask the question, let's say you have, this is the ground. Let's say here's the ground, and there's a water flooding through the ground, right? So water coming in through this ground. So I can take any kind of closed area, surface area, right? I'm not taking like a surface area like this. I'm not doing that. I'm taking a closed surface area, right? So let's say here's the ground. Water's flowing, and I take some kind of closed surface area on the ground. It could be circle, it could be cubic, I mean not cubic, it could be square, circle, any shape, doesn't matter. Now I can ask, what's the total flux going through that surface? If it's 0, that would mean there's no sinkhole there. The water doesn't go in somewhere. There's no little holes or anything. Or the other thing it means is there's no source of water there that comes out. So everything that comes in goes out. Okay? So the water equivalent would mean if there's any source of water in that space, anywhere where the water is bubbling out of there, then the flux would not be 0. Or if there was a sinkhole, the water would be going in, the flux would not be 0 either. If there was a sinkhole, the flux would be negative, right? More flux lines going in than coming out. So it goes in. If there was a source of water there, the flux would be positive. More flux lines, more water would be coming out than in. Well, the same thing goes true here. In this case, there is no charge in this box, right? There's no charge in that box. It's just the box in empty space, and the electric field line is coming here. Where's the electric field line coming from? Well, there must be some source of E field line here. Maybe it's a rod. Maybe it's a rod that is positively charged. That rod is creating this E field, and this box is just somewhere in empty space. So the fact that total flux through it is 0 indicates that there is no Q or negative Q there. You see? There's no Q or there's no negative. There's no source of charge. So that's what brings us now to Gauss's law. Gauss's law says